Dear students, so in this class let us discuss about a second order partial differential equation. So what is the second order partial differential equation? Consider the differential equation or a partial differential equation Ruxx plus Suxy plus Tuyy plus g of x y u ux uy equals 0, where ux uy means del u by del x, uy means del u by del y, uxx second order derivative, del square u by del x square, this is del square u by del x del y, this is del square u by del y square. Okay, then such that here r square plus s square plus t square differs from 0. This partial differential equation is said to be a second order partial differential equation, whose order is second, del square u by del x square and so on. So this types of partial differential equation is said to be a second order partial differential equation, where r square such that r square plus s square plus t square differs from 0, where r, s and t are the functions of x and y, Yes, r and s and t are the functions of x and y only. Okay, so for consider letter u equals f of x plus iy, and or f of x plus iy plus g of x minus iy, where f and g are arbitrary functions. Then what about ux? Here ux is f dash x plus iy plus g dash x minus iy. Okay, what is uxx? Uxx is f2 dash of x plus iy plus g2 dash of x minus iy. Enough. What is uy? Uy is again f dash of x plus iy into i. So I into f of x plus iy minus I into g dash of x minus iy. Again uyy is, that is I square minus 1, that is minus of f2 dash x plus iy. I square is again minus 1 plus, so plus g2 dash of x minus iy. Okay, then here uxx plus uyy, uxx, again there is a minus sign, uxx plus uyy. What is uxx plus uyy? f2 dash x plus iy minus f2 dash x plus iy 0, and this is also 0, then uxx plus uyy equals 0. So this is a second order partial differential equation. Okay, so the partial differential equation is of the form Ruxx plus Suxy plus Tuyy plus Gxyu Uxuy equals 0, where r square plus s square plus t square differs from 0, as well as r, s and t are functions of x and y alone. Such type of partial differential equations are known as second order partial differential equation. Okay, now consider linear one-dimensional wave equation. So for transverse vibration of a string, what is the transverse vibration? Transverse vibration of a string. What is the transverse vibration? So you consider a string. Consider the string, this one. Suppose y equals yxt be the transverse displacement from x-axis. Y equals yxt be the transverse displacement of a string from this x-axis at a time t at a point x. Okay, then consider the small portion of the string. So consider the small portion of the string delta s, let it be between the two portions, or the 2 points p and q of the string. Okay, then consider this p and q are any 2 points on the given string. Let delta s be the small portion between this p and s. So consider this one. So suppose this angle is psi 1, and this angle is psi 2. Psi 1 and psi 2 are the any two angles that made by these points P and Q with the x and y axis respectively. Okay. Then the forces acting at this point P and Q are nothing but the tension only. Let T1 be the tension acting at the point P and T2 be the tension acting at the point Q. Then neglect the weight of the string here. So the coordinates of P is, it is T1 cos psi 1, T1 sin psi 1. T1 cos psi 1, T1 sin psi 1. This is the coordinates of the point P. And that of the point Q, it is T2 cos psi 2, T2 sin psi 2. Agree? Okay. Then consider the motion, equation of motion. In x direction, there is no displacement. Why? In x direction, if there is any displacement in x direction, then the position of the string changes there. So just to be assumed that there is no displacement in x direction. When there is no displacement in x direction means we have T1 cos psi 1 equals T2 cos psi 2. Okay, let it be T. Say it is T. Since there is no displacement in x direction, so their x coordinates are same. That is T1 cos psi 1 is same as T2 cos psi 2, let it be T. If there is any displacement in x direction, then the position of the string changes. Now, what about the force acting in y direction? In y direction, actually the force acting on it is force into, suppose there is a displacement in y direction. If there is a displacement in y direction, then there is a force acting. For the displacement, force is necessary. Let it be F. F is mass into acceleration. We know that force is mass into acceleration. But what is actually mass of a string? Mass of a string is rho into delta S. Mass of a string is rho into delta S. What is rho? Rho be the linear density of the string. Rho is nothing but linear density. So linear density of the string is rho, and delta S be the smallest portion in between P and Q, between 2 points P and Q of the string. So the force acting on the string is nothing but mass into acceleration, where mass is rho into delta S, where rho be the linear density of the string. Also since the force is acting there, then there is a displacement in y direction, means its y coordinate changes. So what is F? Then the force is nothing but it is T2 sin psi 2, that is a displacement, minus T1 sin psi 2. Clear? So that means force is mass into acceleration, but its mass is rho delta S into, what is the acceleration? Acceleration along y direction. Acceleration along y direction means del square y by del t square. Acceleration at any time t. So that is here acceleration A is del square y by del t square. So that means ytt. Okay. So mass into acceleration, rho delta S into ytt. That's force F is same as T2 sin psi 2 minus T1 sin psi 1. Okay. If you dividing throughout by t, what you get? We can divide it throughout by t. So by t means that means a rho delta S into ytt divided by t equals T2 sin psi 2 by t minus T1 sin psi 1 by t. This by t by this by t. Okay, dividing throughout by t, term by term division. Actually, but what is t? T is either it is T1 cos psi 1 or it is T2 cos psi 2. So here t is T2 cos psi 2. Okay, here t is T1 cos psi 1. Clear? That means a rho delta S into ytt divided by t equals, it is sin psi 2 minus sin psi 1. Sin psi 2 s minus sin psi 1. So that means here rho delta s into ytt equals t into sin psi 2 minus sin psi 1. Agree? Actually, what is sin psi 1? Sorry, not sin, it is tan. Sorry. It is tan psi 2 minus tan psi 1. Sorry, if you divide it with that one, so rho delta s ytt is tan psi 2 minus tan psi 1 into t. But what is actually tan psi 1? Tan psi 1 with tan psi 1 and tan psi 2, which are the slope of the string. Tan psi 1 and tan psi 2, tan theta. Tan theta means slope of a string. So tan psi 2 and tan psi 1 with the slope of the string at the point Q and P respectively. Okay, that is the slope. So what is tan psi 1? Tan psi 1 means slope of the string at P means it is del y by del x at P. That is tan psi 1. Similarly, tan psi 2. What is tan psi 2? It is the tangent, or that as it is the slope of the string at the point Q. So it is del y by del x at Q. Okay. So we have what is rho delta s. So from here, a rho delta s into ytt equals tan psi 2 means t into del y by del x at Q minus del y by del x at P. That is tan psi 2 and tan psi 1. Now, what about tan s? What we have? What is del square y by del x square? But del square y by del x square equals, it is del y by del x at P minus del y by del x at Q all divided by delta x. D by dx of, okay, divide delta x then shows 0 of this one. So that means here del y by del x at Q. So that means from here del y by del x at Q is same as del y by del x at P plus delta x into del square y by del x square. Okay. So using this value of del y by del x at Q, substitute here. So the right side will become t into here del y by del x at P. There is minus del y by del x at P cancelling each other. What remains there? Then it remains. It is t into delta x into del square y by del x square. Okay, after substituting the value of del y by del x there. So rho delta s ytt is nothing but t into delta x into del square y by del x square. That means what is ytt? Ytt equals, it is t by rho into delta x by delta s into del square y by del x square. Okay. Del square y by del x square, that is noted as yxx. Now, but what is delta x by delta s? So it is this is delta s, so this is delta x and this is delta y. Okay, so here since delta s is a small portion, that is a very small portion, so it is just a straight line. So from there, by the right angle triangle, delta s square equals delta x square plus delta y square. So delta s is delta x whole square root of delta x square plus delta y square. Okay. So what is delta x by delta s? Means it is delta s by delta x. It is delta s by delta x equals square root of 1 plus delta y by delta x whole square. Okay. Delta x, take delta x outside of here. So it is delta s equals, take delta x outside from here, so delta s by delta x is this. So what is means that implies delta x by delta s equals 1 by square root of 1 plus delta y by delta x whole square. Okay. So from here we know that ytt equals, so what is ytt? It is ytt equals t by rho into, this is 1 by square root of 1 plus delta y by delta x whole square into yxx. Okay, but if mod of yx less than or equals 1, then when delta x is the smallest portion, so when delta x goes to 0, delta x also goes to 0. When delta x goes to 0, yes, then delta x goes to 0 and delta x goes to 0. Therefore, this delta 1 by 1 plus delta y by delta x whole square, that reduces to a very small quantity, so we can neglect it. That's a negligible quantity. This quantity is negligible. So from here we know that ytt equals t by rho into yxx. So t by rho into yxx means, what is yxx? From here yxx is rho by t into ytt. This rho by t into ytt. So it is finally it is rewrite as yxx equals 1 by c square into ytt. So this is the required equation where c square is t by rho. Here setting t square equals c by rho. C square equals t by rho. Then finally we have yxx equals 1 by c square into ytt. Agreed. So this is the wave equation or transverse vibration of a string. So the second order partial differential equation for the transverse vibration of a string is given by yxx is 1 by c square ytt, where c square is t by rho. Clear? So this is the transverse vibration or the partial differential equation or second order partial differential equation for the transverse vibration of a string. Okay. Now let us consider heat conduction equation. Heat conduction equation. Heat conduction equation. So let us consider a homogeneous isotropic solid. Consider a homogeneous isotropic solid. Let V be, it is consider a homogeneous isotropic solid. Let V be the volume element. Let V be the volume element. Then the heat energy stored in delta V. Heat energy stored in delta V is, that is the heat energy. Heat energy stored in delta V equals, it is C rho U dV. C rho U into delta V or dV. Heat energy stored in delta V. Heat energy stored in delta V is C rho U delta V. What is C? C be the specific heat capacity of the solid. Rho be the density of the solid. U be the temperature at a time T itself. What is C? C be the specific heat capacity. Specific heat capacity of the solid. Rho, it is the density of the solid. And U be the temperature of the solid at any time T. So the heat energy stored in delta V is given by C rho U delta V. Okay. Therefore total heat energy. We know that total heat energy equals triple integral over V. V equals total heat energy, let it be V. V equals triple integral over V C rho U delta. So this is the total heat energy. So total heat energy in V. Total heat energy in V is triple integral over V C rho U delta. Why? Because heat energy in delta V, smallest portion, it is C rho U delta V, where C be the specific heat capacity, Rho be the density of that solid, U be the temperature at any time t. Therefore, the total heat energy in V is nothing but it is triple integral over V C rho U delta. Now, let delta S be the surface element, delta V be the volume element, here delta S be the surface element. Delta S be the surface element. Delta V be the, what is delta V? Delta V be the volume element and delta S be the surface element. Then the heat flow across delta S. Heat flow across delta S is given by, it is K delta U dot N ds, N delta S. K delta U dot N delta S. What is N? N be the outward drawn normals to the surface. N be the outward drawn normal to the surface. Means the heat flow is always normal to the surface. This is because of heat flows always normal to the surface. And what is K? K be the thermal conductivity. K means it is thermal conductivity. So delta S be the surface element. So the heat flow across delta S is K delta U dot N ds, where N be the outward drawn normal to the surface. Why? Because of the heat always flows normal to the surface, and where K be the thermal conductivity. Okay. Therefore, total heat flow, total, like this total heat energy, here total heat flow. This total heat flow across S is known as flux. Total heat flow across S. Total heat flow across S is known as flux across the surface, which is known as flux. That is given by, it is given by double integral over S, since it is S be the surface element. Double integral over S K delta U dot N ds. Okay. Now we know that then by divergence theorem, we know that double integral over K dot K delta U dot N ds, delta S is nothing but it is triple integral over V K del dot K delta U del dot K delta U d. This is by divergence theorem. Divergence theorem states that double integral over S K delta U N ds, that is total heat flow across S, that is flux across S is nothing but triple integral over V K delta U d. Agree. Now the